All right, good morning, everybody. So I'm going to be gone today, and I wanted to go over part of your lab from yesterday with the different tests we did for the soil. So this was none of your faults, but a lot of your test tubes, when you were trying to test for the phosphorus and the potassium, there was so much dirt in your sample that it pretty much just looked black. So these have now been sitting overnight. So you can see that they've kind of settled down. And I just want to go over these again a little bit here. So what I did was I went back to the site yesterday after school, and I did my own test so I could get some cleaner samples. So here is the potassium for K there. So this is the color that I got, and this matches most of what you got. I got my sample from right inside the trees there, where I could see there were some dig marks from everybody else. So if we look at the levels of potassium here, I'm going to let you go ahead and decide for yourself. So on your lab, you can use this color as a guide. I don't know whose test tube is whose. Some of these are different. So if you could tell that yours was one of these that's really deficient, well, then you can go ahead and keep that as your result. But if you really weren't sure in your lab, then here you go. I'll let you use this. So I'll leave that right there. Here is my nitrogen, and just like everybody else's, pretty much no nitrogen in that soil, which is a little bit surprising. Here's a test tube from some potting soil, and you can see it's really, really bright purple, and that's because nitrogen is what we call a limiting nutrient. And so potting soil is specifically designed to be super rich in nitrogen. Phosphorus, it looks like we have a pretty wide range here. Some of you saw almost no phosphorus. Some of you, it was pretty highly concentrated. But in that site where I got the dirt from the trees, that is my phosphorus. So I would call that surplus, if not sufficient, right there. And then these pH ones look pretty good. They range from kind of blue to bright green. Mine is fairly bright green, so if we look at that, I'll let you judge that for yourself as to what the pH of that is. So on your lab, if it was really not clear because your sample was super muddy, you can go ahead and use these as your guides, and I'll leave them right there. So on to the next thing, which is over here. So one of the questions in your lab is talking about how can you change the acidity or the pH of river or lake water? If you read through your lab, there are some explanations as to how that is. I think right at the bottom of the very first page, it talks specifically about how algae bloom can make the water more basic rather than acidic. If it says a high pH, that means basic because these numbers are higher than these numbers. Low pH means acidic. Now, in nature, there are ways that the pH sort of balances itself out, right? So through decay, we can get some acid in the water because as things rot, they release a lot of CO2, and that makes the water acidic. But also just through natural acid rain. So what I have here is this stuff. It's a solution of pH indicator. So right now, it's pretty much neutral. It's dark green. But we can change that if I grab a substance here that is basic and I put a couple drops in here. Let's stir it around. Well, that pretty much just made it even more dark green. It's kind of hard to tell, but this stuff changes as you add material in it. So we can add some acid in here, and you can see its color changes. If I add a little bit more, now it should become sort of bright red. You can see the green disappearing, and there you have it. So now it's a fairly strong acid. Okay, so we're going to take this other one and do the same thing, and we're going to use this in a little demonstration here. I wanted to do this in class, but I'm going to be gone today, obviously, so Put a couple of drops in there to make it acidic. Stir that around. Okay, that took forever, but it's finally red. So inside of here, this is, I'll just grab the bottle. These are marble chips. So it's literally just marble rock that's been ground down. Now marble is metamorphosized limestone, and limestone is made primarily of calcium carbonate. Remember, this comes from living shells. And that is exactly what sort of antacid tablets, a lot of them have calcium in them. So we're going to see if this can neutralize what we got here. So I'm going to put this camera out on the stand for a moment. So you can see here is the acid rain, quote unquote, simulation. As it moves through these rocks, it gradually changes its pH and it becomes more and more towards the basic end. I'm going to remove the plug from the bottom here and let the water drain. There we go. So as that starts to trickle down, it moves into the green, which is where the neutral is. So we're starting off fairly acidic, and then as we get down here, the rocks are changing the pH of our substance, and that neutralizes it. So just by some lakes and rivers have some of this maybe limestone or marble rock around them, that helps to just naturally fix the pH, bring it back more towards a neutral level. But other times, maybe if you wanted to engineer a solution, you could simply add this stuff to there. So there you go, works pretty well. Red, orange, yellow, green, and then kind of a little bit of a blue at the end here. You can see the liquid in the bottom is pretty much straight up blue. All right, that's what I wanted to show you. So you can use this for answering parts at the end of your lab there.